We see them pretty much everywhere. Bathrooms, gyms, the doctor's office, the good old weighing scale. But have you ever stopped to think about what's really going on inside that thing? It's not magic, it's physics, and it's actually kind of beautiful. So today, let's peek inside and see how it all works. Yeah, it's a great question, isn't it? I mean, how does it know? You step on it, a number pops up, and that's that. It feels a little bit like magic. But I promise you, the answer isn't magic at all. It actually comes down to this one really simple, really elegant principle of physics.
Okay, so to get what's going on, we got to look inside. And what you'd find in a classic mechanical scale, well, it might surprise you. It's not some super complex system of gears and electronics or a tiny little computer. Nope, it's something much, much simpler. Believe it or not, the hero of this whole story is a spring. Just a single coiled piece of metal. That's it. This one little part is responsible for the entire job of measuring your weight. In a mechanical scale, this thing is the heart of the whole operation.
So you're probably wondering, how can a simple spring do something so precise? Well, here's the thing. The spring doesn't know anything. It's just following the rules. It's obeying a fundamental law of physics, a law that makes it behave in a perfectly predictable way, every single time. And that law has a name. It's called Hooke's law. Now, I know that might sound a little formal and sciencey, but it's a concept you already totally get. Just think about stretching a rubber band, right? The harder you pull on it, that's the force, the more it stretches. Hooke's law just puts that simple idea into a powerful scientific rule. But here's the really important part, the key insight. That relationship is directly proportional. What that means is, if you double the force, you get exactly double the stretch. Triple the force, you get triple the stretch. It's this super consistent, super predictable behavior that turns a simple piece of metal into a precision measuring tool. That reliability is everything. Okay, so how does this connect back to you standing on a scale? Well, it's a perfect setup. Your body weight, thanks to gravity, is the force. And the spring inside the scale, that's what does the predictable stretching. Let's put those two pieces together. And this is the final piece of the puzzle. The scale is basically a stretch measuring device. It's like a translator. See, it's not actually measuring your weight directly. What it is measuring is how much the spring stretches because of your weight. And then a simple little mechanism inside converts that specific amount of stretch into the number you see on the dial. It's just a really clever, really elegant solution. All right, so let's just run through that beautiful process one more time. Step 1, you stand on the scale. That's the force. Step 2, the spring inside stretches out by an amount that is perfectly proportional to that force, all thanks to our friend Hooke's law. And finally, step 3, the scale's machinery translates that stretch into the final reading. Boom, done. You can almost think of it like a little conversation. Your weight kind of shouts down at the spring, and the spring stretches back with a perfect response. It's this incredible little dance between force and extension that makes a simple mechanical scale so surprisingly accurate. So the next time you step on a scale, you'll know the secret. You can picture that simple spring inside, just quietly doing its job and obeying Hooke's law. And as you go about your day, you can start looking for this everywhere. It's in the suspension of your car. It's in the clicky top of a ballpoint pen. Our world is just full of these elegant little systems. So I'll leave you with this. Now that you know the secret rule, where else do you see it at work?